The picture we have of dinosaurs is often that of colossal lizards, scaly, cold-blooded, stupid. But what if that image is wrong? What if these creatures had more in common with us than we think? Today, we are going to find out together if dinosaurs really had fingers. You will be surprised by the answer. To understand whether dinosaurs had fingers or not, it's important to know what a finger actually is. If we're talking about human fingers, we're referring to the digits of our hands and feet, those elongated structures that allow us to grab objects and perform delicate tasks. But this is just one type of digit. In fact, many other types of digits exist throughout the animal kingdom, from the slender digits of a gecko's foot that help it climb walls to the paddle-like digits of a whale's fin that help it steer through the water. So when we ask whether dinosaurs had fingers, we need to be careful to define what we mean by the term. So now, we come to an even more important question. How did life on Earth evolve before the appearance of humans? It was very different from what we know today. And so the concept of a finger as we know it may not have applied to dinosaurs at all. Now, let's get into the science. What makes a finger a finger? When we look at our own bodies, we can see that our fingers are made up of bones called phalanges, which are connected to each other by joints and covered with skin. This structure is unique to our species and is not necessarily representative of how other animals' limbs evolved. But there are some general principles that can help us understand how we got our fingers. Our hands and feet are part of our appendicular skeleton, which also includes our arms and legs. The bones in our appendicular skeleton are not directly attached to our body. Instead, they are attached to our axial skeleton by two sets of limb girdles, the pectoral girdle, which connects our arms to our body, and the pelvic girdle, which connects our legs to our body. The pectoral girdle is made up of two bones, the clavicle and the sternum, while the pelvic girdle is made up of three bones, the two hip bones and the sacrum. These limb girdles provide attachment points for our muscles and allow us to move our limbs independently of our body. Now, let's take a look at how our fingers actually work. Each of our fingers has 3 phalanges, except for our thumbs, which only have 2 phalanges. The phalanges are arranged in such a way that the thumb is on one side of the hand, and the other 4 fingers are on the other side. This arrangement allows us to oppose our thumb to the other 4 fingers, which gives us the ability to grip objects with precision. The joints between the phalanges allow for a wide range of motion, which makes it possible for us to manipulate objects with our fingers in a dexterous manner. Interestingly, the evolution of our hands and feet is thought to have played a crucial role in our ability to walk upright on 2 legs. When we walk, our bodies are in a constant state of balance, and our hands and feet play an important role in maintaining that balance. Our feet provide the base of support, while our hands help us to reach and grasp objects and to push off the ground. The evolution of our hands and feet is therefore seen as a key adaptation that allowed early humans to walk upright and freed our forelimbs to manipulate tools and other objects. But what does all this have to do with dinosaurs? Well, everything. As we mentioned earlier, the concept of a finger as we know it may not have applied to dinosaurs. So to understand whether dinosaurs had fingers, we need to look at their skeletal structure and compare it to that of other animals. Dinosaurs were a diverse group of reptiles that lived on Earth for over 165 million years. They first appeared during the Triassic period and went extinct during the Cretaceous-Paleogene extinction event, which also led to the extinction of the dinosaurs. Non-avian dinosaurs are divided into 2 major groups, the Saurischia and the Ornithischia. The Saurischia, or lizard-hipped dinosaurs, include the theropods and the sauropods. Theropods were mostly carnivorous dinosaurs with hollow bones and a distinctive hip structure. Sauropods were herbivorous dinosaurs with long necks and tails and thick, sturdy legs. The ornithischians, or bird-hipped dinosaurs, include a wide variety of plant-eating dinosaurs with a distinctive hip structure. When we study dinosaur fossils, we can learn a lot about their anatomy, behavior, and way of life. For example, by studying the shape and structure of their teeth, we can determine what they ate. By looking at their bone structure, we can tell whether they were fast or slow moving. And by studying their footprints, we can learn how they moved and interacted with their environment. One of the most interesting things about dinosaurs is that they are incredibly diverse. There were all shapes and sizes, from the tiny Compsognathus, which was about the size of a chicken, to the huge Argentinosaurus, which was over 100 feet long. This diversity is reflected in the fossil record, which shows that dinosaurs were able to adapt to a wide range of environments and ecological niches. Now, let's get back to the question we posed at the beginning of this video. Did dinosaurs really have fingers? To answer this question, we need to look at the hands of a few dinosaurs and compare them to the hands of other animals. The first dinosaur we'll look at is Ankylosaurus, a herbivorous dinosaur that lived in what is now North America during the late Cretaceous period. The Ankylosaurus was a large, bulky dinosaur with a long tail and a distinctive bony armor that covered its body. The dinosaur's skull was also quite distinctive, with a long, narrow snout and a row of sharp teeth along its upper jaw. However, it was not a true mammal, as it was a reptile with scales and laid eggs. The Ankylosaurus's hands were small and clawed, which would have been useful for climbing and maneuvering in dense undergrowth. However, its claws would not have been suitable for grasping objects or performing precise movements. Next, let's look at the hands of Velociraptor, a carnivorous dinosaur that lived in what is now Mongolia and China during the late Cretaceous period. The Velociraptor was a relatively small dinosaur with a long, slender body and a large head. Its skull was equipped with a powerful bite and sharp, curved teeth for catching and tearing up prey. The Velociraptor's hands were long and slender, with 3 or 4 fingers at the end of each hand. This would have been useful for grabbing onto prey and for climbing and maneuvering in dense undergrowth. The Velociraptor's fingers were also flexible and could be used to perform precise movements, such as manipulating a tool or buttoning a shirt. Finally, let's look at the hands of Tyrannosaurus rex, the most famous carnivorous dinosaur that lived in what is now North America during the late Cretaceous period. The Tyrannosaurus rex was a huge dinosaur with a massive head and a long, powerful tail. Its skull was equipped with a huge bite force and large, serrated teeth for crushing and tearing up prey. The T-Rex's hands were small and robust, with 2 fingers at the end of each hand. These would have been useful for gripping and holding onto prey, and for maneuvering in dense undergrowth. However, the T-Rex's fingers were not particularly flexible and would not have been useful for manipulating objects or performing precise movements. So the answer to the question, did dinosaurs have fingers? Is that it depends on what we define as a finger. If we're talking about human fingers, then the answer is no. Dinosaurs did not have fingers because their hands were structured differently than ours. However, if we're talking about any kind of digit, then the answer is yes. Some dinosaurs, like the Velociraptor, had fingers. It's important to remember that dinosaurs were a diverse group of animals, and not all dinosaurs were created equal. Some dinosaurs were small and agile, while others were huge and lumbering. Some were herbivores, while others were carnivores. And some had feathers, while others were completely naked. So it's not accurate to make sweeping statements about dinosaurs as a whole. Each type of dinosaur was unique and adapted to its environment in different ways. In recent years, new discoveries have shed light on the evolution of dinosaurs and their relatives. One of the most exciting discoveries is the realization that dinosaurs and birds are closely related. In fact, birds are considered to be the only surviving group of dinosaurs. This discovery has led to a reevaluation of what we thought we knew about dinosaurs. For example, we now know that many dinosaurs, including some species of Ankylosaurus, had feathers. We also know that dinosaurs were much more diverse than we previously thought, with some species living in herds and others being active at night. As we continue to learn more about dinosaurs, we can appreciate the incredible diversity and adaptability of these creatures. They were truly the masters of their time, and their legacy lives on in the birds that share their DNA. And here, we come to the end of our journey through time. We hope you enjoyed learning about dinosaurs and their relatives, and we encourage you to keep exploring the world around you. Who knows what amazing discoveries you might make? Maybe you'll even discover a new species of dinosaur, or find a way to bring dinosaurs back to life. Just kidding. But hey, who knows? Anyway, thanks for watching and see you next time.